Okay, welcome to 1050, the review day 1. To get us started, just some of the things. Hey, this week we're going to complete the final from fall 2012, and we'll go over that in class. Your final has 25 multiple choice questions. Remember, that's all or nothing, right? You either get the question right or you get it wrong, so make sure you spend the time kind of plugging it back in. 4 points each. So it's all equally weighted. Still show your work. Because if you do really bad, but you're close to that passing grade, I'll go back and look at your work. The time limit is 150 minutes, and I split into 2 parts. 78 minutes for the first 13 questions, which we'll do on day 1, and then 72 minutes for the last 12 questions, which we'll do on day 2. It will be 2 days. It will be the 18th and the 20th in class. There's no test makeup, so make sure you communicate earlier if you're going to be gone. You don't get a note card, but you do get an equation sheet, although it is blank. I'll give you the same one to use both days, though, so if you can write it down the first day, you can then use that same one for the second day. Remember, if you fail the final, the highest grade you'll receive in the class is a D. Also, take a moment this week to check your Slick/Skyward grades. I'll do my best to update those, but if they're slightly outdated, I do apologize. I guess I'm having fun with my baby. Be aware of some things that I will do to help you out, and then I'll let you know when grades are finalized. You can come in and talk to me before I actually post them. Is if your score in the final is better than your average midterm, I will count the final as a 4th midterm. And at the end of the semester, I will drop the lowest 3 homework assignments and lowest quiz grade. So let's talk about how you should prepare for the final. I would definitely look at your quizzes, and there's even some practice quizzes by chapters underneath that module. I look at previous finals, even though it's maybe a little bit different format, because it's all multiple choice this year. Hey, that's going to help you. You can look at your notes, form a little study group, etc. Okay. So let's start off. We're going to go over chapters 1 and 2 today. So remember even. So what's the difference between even, odd, or neither functions, and how do you determine algebraically? So even functions, remember, they're symmetric about the y-axis, right? And I would think about something like x squared, right? X squared is symmetric. Hey, what's true about it? No matter if you plug in f of x or if you plug in negative f of negative x, you should get out the same result. Odd is symmetric about the origin, but I usually think about that as a rotation of 180. And that means that negative f of x equals f of negative x. And last but not least, neither means not even nor odd. Okay, so we're going to look at a few examples and determine if these are even, odd, or neither. I say you must show your work, but the reality is in the final, it's up to you because it's multiple choice. So I always start off and I'm like, okay, let's plug in negative x. So I have negative x plus 1, and then negative x squared minus 5. So we get negative x plus 1, and when you square a negative, you'll still get a positive. So it is not even. Okay, so now let's negate the function. So you can put a negative up front, but I think sometimes that's a little confusing. You can leave it like that. In this case, it's the top that looks a little bit different, so I would maybe just think about distributing that negative to the top. And notice that these two don't match either. F of negative x and negative f of x don't match in either, so it's not odd either. So this one is neither. Okay, on this next one, let's see, what's g of negative x? If I negate something in the absolute value, I'm simply going to get a positive value. Right there, it tells me that we have an even function. You can check odd, it's not going to hurt anything, but notice we'd get a negative here and then it changed to a positive. So it's not odd. Okay, let's take a look at the next thing, domain versus range. So domain is your x values, and range is your y values. You can either write your answer as an interval, or if it's just a single value, sometimes we do like x equals, kind of like y does not equal for domain and range. Okay, so let's go ahead and let's start by finding the inverse here. So if we're trying to find the inverse of this function, what I'm going to do is I'm going to rewrite it with a y. And the idea here to find the inverse is swap x and y, solve for y. Okay, so we get x equals 2y minus 5 over y plus 3. Then I'm going to multiply both sides by that y plus 3. So I get xy plus 3x equals 2y minus 5. Remember in this case, we do want to get it, our y's on the same side, the other part's on the other, so I'm going to add the 5 and subtract the xy. So we get 3x plus 5 equals 2y minus xy. So let's factor out the y. We get 2 minus x. So y equals 3x plus 5 over 2 minus x. We may put it in the notation of the inverse. So the little f to the negative 1. Okay, this is the way we solve it. Remember, it's multiple choice, so depending on the way you put your y's on like which side, if you would have done the other way, this is equivalent to negative 3x minus 5 over negative x plus 2. So if I negate the top and bottom, those are equivalent answers. So just be aware that if your answer isn't quite matching up, it could be either of those formats. Okay. So that's what we got here, 3x plus 5 over 2 minus x. Or I could call it negative 3x minus 5 over x minus 2. Okay, so let's talk about the domain. There's two ways to kind of think about this. The domain of the original one is we can't have the denominator equal to 0, so we can't have it be negative 3. If we look at the inverse, we can't have x be 2, right? That's going to make the 0. So then for the range, we can think about flip-flopping it. This will now be y cannot be negative 3. And we're going to put that there, so y cannot be 2. The other way to look at it is think about it in terms of dividing the x values, right? So the other way I could think about it is, as you look at the coefficients here, right, negative 3x over x is also the same. So for domain, denominator equal to 0. For range, you can think about it two ways. Swap domain. You can think about it as the inverse. So domain of inverse. Or you can think about it as a rational function. So the coefficients of x's. Okay, let's go ahead and let's look at the next thing. So composition of functions. So g of f. That means we're taking our function g and we're plugging in f of x. So we're going to take g and we're going to plug in 3x. So wherever I see x in my equation, I'm going to plug in a 3x. So I get 12x over 3x plus 1. Okay. Same thing with this one. G, and I'm going to plug in x plus 1. So I get 4 over x plus 1 squared minus 4. I'd recommend, maybe we'll run the side here, x plus 1 squared. I think a lot of you need to rewrite it as x plus 1 times x plus 1. So you get x squared plus x plus 1 So we get x squared plus 2x plus 1. So we have 4 over x squared plus 2x plus 1 minus 4. So 4 over x squared plus 2x minus 3. Okay. So if I now ask you for the domain and range of your functions, sorry, up here I realized I forgot the 1. Let's start with domain. So domain of this would be that 3x plus 1 cannot be 0, so x cannot be negative 1/3. Same thing with this. The domain is I do not want the denominator to equal 0. So we want to think about factoring this. So x cannot be 1 or negative 3. Okay, for range, think about if there's any asymptotes. So think about your rational functions. This would be y equals 0, and so would this. Range y cannot be 0, just based on the fact that those are rational functions. Oh man, I totally messed up on this one. Let's look at this top one again, sorry, real quick. This should have been x on top, which will influence your range. Since the coefficient on the top and the bottom are the same, we're going to divide that. So y cannot be equal to 12 over 3, so y cannot be 4. Okay, so as we think about those, the one thing you may want to consider, I know when we did this, if there's any domain restrictions of what you're plugging in. So if there's any domain restrictions of f, then you'd want to plug it in and just be careful. But there we go. We can just go ahead. We found it at both, so I'll just say C above. Okay, let's go ahead and take the next. So the difference quotient. They will always give you the formula. But then you need to know how to use it. So in this case, we want to go ahead, and I would start off, and I usually find f of x plus h. And we're going to square it, and then we're going to plug in f of x plus h here as well. I'd go ahead and expand x plus h squared. So sorry, I rewrote it. I don't need to have it squared anymore. But when I do that, I get x squared plus 2xh plus h squared. So I end up with negative 2x squared minus 4xh minus 2h squared plus 5x plus 5h minus 1. Okay, once I do that, I usually take that quantity and I subtract f of x from it. So I get negative 2x squared minus 4xh minus 2h squared plus 5x plus 5h minus 1, and then it's going to change the signs of our original function. So plus 2x squared minus 5x plus 1. And you'll notice, if we've done things correctly, that all I should have left is terms that have an h with it, which in this case, I do. Okay, so then last up is we're going to take what we just found, and we're going to divide it by h. So you can either think about factoring out an h, or I think a lot of times they're just like, okay, the h will cancel out from one of each of the terms. So I get negative 4x minus 2h plus 5 is the difference quotient. Okay, one more for you to do. Let's look at the next one, f of x plus h. So start off again, 3 times x plus h squared plus x plus h. I'm going to take a little bit of a shortcut here, since we just expanded it, and rewrite it in expanded form. And now let's distribute the 3. So all you're doing here is plugging things into an equation. But it's, do you know how to plug into that equation and what that equation actually does with it? So I'm going to go ahead and subtract my f of x from my next step. So rewrite what we have above and negate my function. So negative 3x squared minus x. Okay. Got some terms that cancel, so I got 6xh plus 3h squared plus h. Last but not least, I'm going to divide everything that I just got by h. Okay, so we can totally think about it the way we just did, but be a little careful, because if you do that, this really is 1 now. So another way you may want to think about it, and it's totally up to you, but is factor out an h, because then I think you'll notice that 1. So we do get 6x plus 3h plus 1 as a final answer. Okay. Tell your neighbor what these functions look like. So the reason why I say that is because, hey, you got to be able to graph them. So especially with piecewise functions, they're just expecting you to know what these look like. You can always plug in some points, though. So like, hey, this is, a straight line. This is slanting up. This is a u. This looks like this. A square root looks like that, starting from the origin. A cube root goes on its side, and, we get something like this. We've got a V shape, we got like that, and we got like this one. At the end of the day, though, if you're ever in doubt, just plug in some points. So now the reason why I had us do that is because I am giving you a piecewise graph, and I want us to go ahead and be able to graph it. So I'd start with a linear one. Hey, we're at positive 2, and I have a slope of negative 1. But notice we're only doing this when x equals 1, so the left side of that cut off. Okay, so it's really to this side of it. And we know at 1 it's an open circle, and we're keeping this left portion because it's when it's less than 1. But when in doubt, you can make a table of values. So like, hey, if you are getting stuck, right, maybe you're doing something like this. So either graph and erase the part you don't need. Or I would say a table of values. So something like, hey, x, y, and we see that 1's the cutoff, so maybe I do like negative 1, 0, 1, 2, 3, 4. So like, hey, here I'm really doing a negative of a negative 1 plus 2. So 1 plus 2 is 3. I'm doing a negative of a negative 1 plus 2, and I get 0. Negative of a 0 plus 2 equals just 2. Negative 1 plus 2 equals 1. But that's like the turning point, right? So be careful, that one's not actually included there. Technically at that point, that's the ending point. That's where it changes. So I'd actually have to do the square root of 1 plus 3. So 1 plus 3 equals 4. The end of that first one, though, if I do negative 1 plus 2 equals 1, this is the open circle at 1 for the left function. So this is kind of where it changes. Changing point. And if I keep going, I've got square root of 2 plus 3, which isn't super nice. Square root of 3 plus 3 is not super nice. Square root of 4 plus 3, though, is 2 plus 3 is 5. So I had to see about graphing those 2 points. So I've got 1, 4. And then I've got 4, 5. That one is a closed circle, so it looks like this. Or I could think about it as taking, my absolute value graph and shifting it up 3. Okay, As you do think about transformations, I've got them all here, and it's not to say you have to be able to do every single one, but I think it's good just to recognize it. Hey, when we add something goes up, subtract goes down. Inside the parentheses, the opposite. We got left and then right. Negating it out front is the reflection over the x-axis. Inside the parentheses is the reflection over the y-axis. When you multiply by c out front, we've got a stretch, a vertical. So vertical shrink if it's a fraction between 0 and 1, and a vertical stretch if it's greater than 1. And it multiplies your y values. The horizontal ones are tricky, and occasionally they will give it to you. Just remember it's like the opposite of what you expect. You divide your x values by c. So we've got a horizontal stretch and a horizontal shrink. I think with this one I'd say, hey, not as important, but I would remember that it's got to be in factored form when we're doing these. Okay, so this is a multiple choice question. Just be careful that you go through and you do it step by step, because it's not always in the order that we want. So the first thing we do is we shift it up 6 units. Okay, the second thing we do is go left 3 units. And then the last thing, since they shifted over the x-axis to end with, notice how it will negate the entire function. So the correct answer here was D. So we also be careful about order. Right, we usually do stress. So stretch, reflect, shift. But do you see how in this case they reflected at the end, so that order changed things a little bit. Okay, so now let's go ahead and let's graph the function by starting with the graph, the basic function, then using techniques of shifting, compressing, stretching, and reflecting. So first, let's think about, hey, what's going on here? So the first thing that I see is that negative up front, so we've got a reflection over the x-axis. Then we've got, it's going to have to go to the right 2 and up 9. This is nice because you can kind of check the values, but the reason why I kind of have me think about it as the transformation is because what if I gave you a graph that was just some points to begin with, and then you were doing these things? So I've got my original graph that's something like this, right? So this is the original. Okay, so now I want to reflect it over the x-axis. I'm going to have something like this. So this is step 1. Okay, now if I move everything 2 to the right, I'm now going to be on the x-axis, and it will look something like this. Last but not least, if I shift it up 9, I'm now going to have that same graph, but up here. So this vertex now is at 2, 9. Okay. I don't know, I threw an inequality over here. Let's go ahead and see what this looks like. I think I did this so you think about it in terms of a graph. I don't know, but we'll go ahead. So we've got x, I think I thought this was a quadratic, but it's clearly not. So whatever, still good practice. X times x squared minus 5x minus 14 is greater than 0. So let's go ahead and factor it. So here my zeros are -2, 0, and 7. Whether you think about this as a graph or as, so we've been better down here, sorry about that, etc., or you want to think about plugging in points. A lot of times I did the factors, so like x minus 7, x plus 2, and we just kind of plugged in numbers, so like -3. We get a negative, and a negative, so this interval is negative. We plug in a -1. We get a negative, and a positive, so this interval is positive. Plug in a +1. I get a positive, I get a negative, and a positive, so negative, and this would be positive. Since we want the positive parts, we want this and this part of the interval, and they are open circles. So we're going to go with B. Okay, next one. Ooh, this looks really hard. X to the 8th, 3x to the 4th minus 10 equals 0, but just remember, hey, we can use u substitution when it follows this format. This is really saying like u squared minus 3u minus 10 equals 0. So remember, you've got 3 terms, and the first term is like twice the squared of the middle term. That's a good sign. So you get u minus 5, u plus 2 equals 0, so u equals 5, u equals -2. So now I'm going to go ahead and plug in x to the 4th. So I'm going to take the 4th root of both sides. Okay, so you'd say x equals the 4th root of 5, and then this one we actually don't use because it does not exist because it's imaginary, right? So there's really only one solution here that we're going to focus on. You know, there could be other examples, right? Other examples may not be as obvious, right? Because you may get in this trap like we did on the test with this one, where you want to kind of use the rational root theorem, but you're going to waste a lot of time. Other examples would be something like x to the 2/3 minus 7, x to the 1/3 plus 10 equals 0. And then you can factor it. Okay. So now let's go ahead and let's look at graphing polynomials. So sketch the graph of an even versus an odd. So even, and then odd degree polynomial, and tell if the x, how can you tell if the x-intercepts crosses or touches? Okay, so for even, we've got, if it's positive coefficient, so let's look at the coefficient. The leading coefficient, maybe I should say. So if we've got a positive and it's even, or a negative, positive means both ends will go up, negative means both ends will go down. Odd, we could also have a positive or a negative. Positive will start low and high, negative will start high and low. If an x-intercept touches, it means the multiplicities. We're going to be looking at the multiplicities. So multiplicities. If it's got an even multiplicity, it's going to touch. If it's an odd one, it's going to cross. Okay, so find the x-intercepts and their corresponding multiplicities, and then the y-intercept as well. So a lot of these they'll ask like, hey, what is the x-intercept? In this case, when you set the first set of parentheses, 2x plus 1 equal to 0, we get x as -1/2, and we also get 3. The multiplicity has to deal with the exponent. So in this case 2, or this case 1. which means that this touches, or you can think of it as bouncing, and this crosses. As for the y-intercept, we're going to plug 0 in for x and see what we get out. So 2 times 0 plus 1 squared, 0 minus 3, negative 1, 1 squared, negative 3, so negative 1 times negative 3 gives me positive 3 as my y-intercept. So the degree here I think is important to note. 2 plus 1 is degree 3, and we've got a negative coefficient, which means it starts high, ends low. So as we start plotting things, we've got a y-intercept, an x-intercept, and another x-intercept. It's going to start high, go up to that point, and come and end low. Oh, I graphed that wrong. Sorry, I graphed 1 rather than 3. Let's try that again. So, starts high. Oops, I gotta kind of come down steeper. Go up to that point. It's probably gonna come up a little bit higher and then low. I wouldn't worry about kind of where the maximum is as long as you connect the points, you're good. Okay, you try. So on this one, I gave you a graph and I want you to figure out which of these is correct. So I may look at this like, hey, this factor is x minus 1, and it's got to be even in the exponent, right? This one crosses, so it's going to be like x plus 1. It's going to be odd. And then I'm also going to say, hey, likely, like, degree 3 because it's flat. And then this one as well is like x plus 2. It's going to be odd. And then likely degree 1 because crosses right through. So let's just see those things. So like as we look at this first one, even, odd, that looks good. This one, because x plus 1 is even, we know is wrong. Okay, that one looks okay. X plus 1 is even, that's wrong. Okay, and then x minus 2 is incorrect. So we're down to kind of these 3 different options. Okay, notice they all have the same exponent, so we just got to decide the coefficient. So whether you want to go ahead and plug it in, I would maybe think about finding like p of 0 and seeing which one actually gives you a y-intercept of 2, or you could kind of write it and then solve. So 2 times negative 1 squared times 1 cubed times 2. So notice how this gives me 4, so it can't be that. And then this one, when you plug in 0, I get negative 1 squared, 1 cubed times 2. I also get 4. It can't be that. It's got to be this, but let's just double check. We get negative 1 squared, 1 cubed 2, so we get a y-intercept of 2. Okay, on this next one, you probably could do it on your own, but we want to go ahead and find all the potential zeros. So remember, we're going to look at the factors of p over q, where p is the last term and q is the first term. So doing plus or minus, I guess I should say maybe factors of 2 over the factors of 6. Plus or minus 1, plus or minus 2, all over plus or minus 1, 2, 3, and 6 for that one. So as we think about dividing each of those, we do end up getting B. Something you'll notice is that D has too many options, like 3 and 6 will never result. And then here, like 3 does not work out, right? So it's got to be one of those first two, and then you can kind of check it from there. Okay, so with that in mind, Given that a real zero function has x equals 1, find all the other real zeros. So I'd go ahead and use our friend's synthetic division. Bring down the first number, multiply by the number in the box. So that number in the box should be a -1. Oh, x equals 1. No, it is just positive 1 because I already gave it to us as a 0. So then we get -4. We get 1. We get 1. That's a 0. That's a good sign. The resulting polynomial then is x squared minus 4x plus 1 equals 0. I'm trying to solve that. Fortunately, it does not factor, so I will have to use the quadratic formula. So x equals -b, so the positive b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So we got 4 plus or minus the square root of 16 minus 4 all over 2. 4 plus or minus the square root of 12 over 2. You could leave it like that, or it's likely that they may simplify it. So something like this, which we could take one step further. 4 divided by 2 is 2. 2 divided by 2 would just leave me with the square root of 3. So the real zeros are 1, 2 plus the square root of 3, and 2 minus the square root of 3. Okay, this next one, when it says form a polynomial with real coefficients having the given degree in 0, so degree 3. Problem is, if it's degree 3, there should be 3 zeros, but I only see 2 here. So remember that it always comes in conjugate pairs. So even if it doesn't write it, you've got to write the other one of 4 plus 2i. Okay, so now let's write it in factored form. If you've got a 0 of x minus 3, you're going to have x plus 3. If we do x minus 4, it also changes the 2i to be positive, the negative 2i to be positive. Think about this other one, will still be minus 4, but it's going to change the imaginary part of it. If we're smart, then we're going to go ahead and we're going to multiply the imaginary parts first. Because as you multiply the imaginary parts, you should get something that's real. I usually use the box for this just to keep my thoughts organized, but you do not have to. Okay, so you'll notice the imaginary parts cancel out. The one thing that you will want to kind of note, remember though, is that I squared is -1, so this box is really 4. If I combine the 16 and 4, this is going to be plus 20 at the end. So x squared minus 8x plus 20 is what that all simplifies down to. Okay, so f of x equals x plus 3 times x squared minus 8x plus 20. So go ahead and distribute. We get x cubed minus 8x squared plus 20x. Now distribute the 3 plus 3x squared minus 24x plus 60. Combine your like terms. And our ending polynomial is x cubed minus 5x squared minus 4x plus 60. All right, that brings us to the end